Okay, welcome everyone to the last database seminar. We saved the best for the last, I guess. So my name is Arun, and today we have an exciting external guest speaker, Professor Jiannan Wang from Simon Fraser University. So Jiannan is a well-known name in the data preparation area in the database community, and he is an associate professor and director of the professional master's program there at Simon Fraser. And he was a postdoc at the AMP lab before that. And he has received numerous research awards, including the TCD Rising Star Award, CS-CAN, InfoCAN Outstanding Early Career Researcher, and several paper and other fellowships awards as well. So Jiannan has been working for almost a decade now in the data cleaning and data integration and data preparation space. And so he's going to be sharing with us about his recent work on this DataPrep tool for accelerating data preparation for AI. Protocol for the talk, Jiannan is okay with questions during the talk as well, so feel free to unmute yourself and ask questions or post on the chat. I will also be monitoring the chat for questions, and we'll also have Q&A at the end. So without further ado, Jiannan, over to you. Thank you for joining us.
Thank you so much for inviting me to give the talk at the Database Lab research seminar. So today I'm going to talk about Dataprepare, a system that we have been building for the past 2 years, which aim to accelerate data preparation for AI. So we know that in the past decade, people have been talking about data scientists spend over 80% time on data preparation. So there's a joke made by this guy called Big Data Borrit, saying that we spend 80% time on preparing data and 20% time complaining about need for preparing data. And at New York Times, and there's an article which interviewed hundreds of data scientists, and a lot of data scientists complain that they spend over 80% time on data preparation. So this is a big issue for the last decade. But the question is, has this issue been solved right now? Unfortunately, it hasn't been solved. So last year, Anaconda, which is a famous data science company in the US, did another survey. They interviewed thousands of data scientists, asking them, what are the challenges you face every day? So here's the one sentence I covered here. It said that we were disappointed, if not surprised, to see that data wrangling still takes the lion's share of time in a typical data professional's day. So early this year, and Andrew Ng is a famous researcher in the ML community, and he launched a campaign and urged the machine learning researcher to focus more on the model data-centric AI. He said that if 80% of our work is data preparation, then ensuring data quality is the most important work of a machine learning team. So we know that people have been complaining for 10 years, but apparently the problem hasn't been solved. Then there are a couple of questions that I'm quite curious to answer. First is, what makes data preparation hard? Why has this problem not been solved in the past decade? How to solve it in the next 5 or 10 years? So let me pause for a little bit so that you can read through those questions. And you can also try to ask yourself those questions. So next, I'm going to share my personal view about the answer to those questions. As I said, it's my personal view. I hope that at the end of the talk, we have the chance to discuss and share our own opinion and work together to solve this important problem in the next decade. So let's come to the first question. What makes data preparation hard? So I'd like to use cooking as an analogy to answer this question. I'm pretty sure everyone here has cooked. And you can ask yourself how much time you spend on preparing food. I believe that most of you will say I spend more than half of time on preparing food. Then the question is why? Why do we spend so much time on preparing food? So I think the first reason is not a single problem. You have to have many steps. Say you have to buy stuff from different places. You have to wash them in different way. You have to cut them in different way and mix them in different way. Use different kind of gradient. So it's also true for data preparation. When people are talking about data preparation, sometimes they may refer to different things, different tasks. So data preparation is not a single problem. It consists of too many tasks. For example, you may have a date column. You want to standardize the date, or you may have the customer address. You want to dedupe the address. So those are different tasks. And the second reason is that let's think about cooking. So sometimes when we think about how should we support preparing food for different kind of people, if it's an experienced chef, the kind of tool they use will be different compared to some beginners who just learn how to cook. So it's also true for data preparation, because data scientists typically have different levels of expertise. Someone may come from the CS background, is very good at programming, but do not have a lot of experience in domain knowledge. But some may very good at machine learning, but doesn't know programming very well. So we have to figure out how to build tools for data scientists with diverse backgrounds. So that's the second reason why building a data preparation tool is hard. The third reason is data preparation is a domain specific. Say for the cooking, if you prepare food for Chinese dishes, it will be different from preparing food for French dishes or Indian dishes. So here is for data preparation is the same. If you prepare data for financial domain, it will be different from preparing data for healthcare domain. Okay. So here are the three reasons I think that make data preparation extremely hard to solve. Now come to my second question: why has this problem not been solved? So I'm going to answer from two perspectives. Let's take a look at the academic perspective. So there are decades of research on data preparation or related problems like data cleaning and data integration. Here I listed three papers. Those papers all got thousands of citations. And interestingly, all those three papers, the first one is the book. The three articles they published about 20 years ago. So typically people will write a survey paper once the field is kind of mature or already have a lot of work, which means that 20 years ago, there has already been a lot of work on data preparation, data cleaning, and data integration. And also in the last 20 years, there's also a lot of work on this topic. But again, so the problem hasn't been solved. What's the reason? So in 2018, a group of distinguished database researchers, they get together in Seattle. So they discuss what are the issues of the database community and what are the important problems we should work on in the next 5 years. And they wrote a report. This report published at Sigmod Record in 2019. So they also discussed this issue in the report, which I totally agree with. So they mentioned, again, data scientists repeatedly say that data integration and data wrangling is 80% of their challenge. So here I highlight the reason that they identify is that in the past, we have focused much of our efforts on solving point problems, such as algorithms for specific challenges, such as entity resolution. So what it means that we have developed techniques for each individual data preparation task and algorithm. We haven't figured out how to build an all-in-one data preparation system that can have data scientists to solve a large variety of data preparation tasks. Okay, so that's the reason why in academia we haven't solved this problem. So in industry, and if there's a point, then industry people should invest effort to solve the problem. Okay, so let's take a look at how they solve the problem. So we know that Aaron organized a panel in Sigmod this year, and talking about can we automate data preparation. So I think the opinion from the panel is it's impossible, and it's very hard. And I agree with that. I think that way to solve data preparation is it has to be human in the loop. So it means that human have to, it means that the system should provide a user-friendly GUI for the user to manipulate the data. Okay, so then there are three directions in terms of the type of GUI that the industry people have provided. So spreadsheet GUI, workflow GUI, and notebook GUI. So here I show you a screenshot of spreadsheet GUI provided by Trifecta. So you think of it like the Excel, but it enriched Excel with some data preparation related operators like standardized date or extract the data from text. Okay, so this is the first direction. We try to extend the Excel to support more data preparation tasks. So the second direction, which I call here the workflow GUI. So here is a screenshot from the product built by the Alteryx. It's a US company. So the idea here is let's model each data preparation operator as a node in a deck, and then we are going to go put the data on the left-hand side, and the data will go through the deck, and then output a prepared data set. Okay, so for example, an operator can be the filter, can be the join, can be the cross tab. So this is the second direction. There are many products that use this idea to build the data preparation solutions. So the third direction is to adopt the notebook GUI. So you can think of notebook as the next generation of command line. So for command line, we can type some command, and then it will give us the output in text. But for notebook, we can not only type command, but also put some code. And in terms of output, it will not only give us some text, it can also give us, say, the HTML page or the table or figure or graph. So it actually enriched the command line significantly. And the reason, so this is the most popular environment among data scientists. The reason data scientists like this kind of environment is it's very flexible. You can do whatever you want to manipulate the data. And also it has this interactive experience, which you can iteratively explore your data and figure out what should be the right way to manipulate the data and prepare the data. So that's why it's the most popular platform among data scientists. Okay. So now come back to our question: why has data preparation not been solved by industry, or why data scientists are still complaining about data preparation? So here I list popular data preparation products. If you look at them carefully, basically all of them adopt spreadsheet or workflow GUI. So this kind of GUI is good for non-programmers to enable non-programmers to do data preparation. But this is not the type of the GUI that data scientists like to use. So data scientists like to use notebook GUI. But if you ask me to say what are the popular notebook GUI-based data preparation tool in industry, I really cannot find any. So that explains why in industry this data preparation problem hasn't been solved in the past decade. Okay, so now it come to the third question: how can we solve it in the next decade? Okay. So to answer this question, let's take a look at how other problems have been solved. Say machine learning pipeline. Before scikit-learn, it's not easy to build a machine learning pipeline because you either have to figure out how to combine the multiple library, or have to implement some function that has not been implemented in those library. But because of scikit-learn, the learning pipeline is super easy to construct. Okay. And for big data, so before Spark, it's very hard to extract value from big data. But Spark makes it extremely easy to process and manipulate the big data. It has this data RDD API and the data frame API that enable even undergrad students who don't know anything about distributed system to extract value from the big data. So the way that big data is solved is that because of Spark. So for deep learning, it's the same thing. So before PyTorch, scikit-learn, or before PyTorch and TensorFlow, deep learning is not easy. And AI experts, they have to build up their own function to implement some neural architecture. But because of PyTorch and TensorFlow, it's extremely easy to build a deep learning model. So which means that the reason that deep learning is solved is because of the PyTorch. So for data preparation, I believe the same thing will happen in the next decade. So if you really want to solve data preparation, we have to build a system which is like scikit-learn, Spark, and PyTorch. And fortunately, in our community, we have already started this effort, and there's a couple of systems have been recently built. And for example, the Dataprepareeda is the one that I'm going to present later. Big Gorilla is the one that's led by Alon Holloway and Anne Haidou. And the Sorting Hat is from the UCSD Aaron is leading it, and the Data Serializer is led by the MIT. Okay, so next I'm going to mainly talk about the system, the data prepare system that we have been building the past 2 and 3 years. Dataprepare is the open source Python library, and which aim to accelerate data preparation for data scientists. So currently we received over 1,000 stars on GitHub and has been downloaded by over 300,000. And it has attracted over 30 external and internal contributors. So our package currently we have 3 main modules. The first one is called connector, which aim to simplify data collection. The second one is called Dataprepare.eda, which aim to simplify exploratory data analysis. The third component is called Dataprepare.clean, which aim to simplify data cleaning. So we are also planning to add 2 more modules, the Dataprepare.feature, which aim to simplify feature engineering, and Dataprepare.data-integrate, which is for the data integration. And more modules will be added in the future. And so in the following, I'm going to dive into the Dataprepare.eda because this is the most mature module. And I'm going to also talk a little bit about Dataprepare.clean, and then briefly mention Dataprepare.connector. Okay. Let's first talk about the Dataprepare.eda. So the key idea of this Dataprepare.eda is a task-centric. So I'm going to explain what I mean by task-centric. So let me first define what EDA is. So EDA stands for exploratory data analysis. It's basically the first step that any data scientist is going to do whenever they have a data set. Say, if you have so the way you understand the data, so EDA is a way to understand and validate data by creating visualization or data summarization. So let's consider example, say you have a student table that consists of all the students at UCSD. And once you get this table, the first step you want to understand it. Say you want to understand the age column to see whether age has some dirty values and what's the distribution of the age. And maybe you are going to first create some statistics, data summarization, like the minimum, the 5 percentile, the 25 percentile, the median, and etc. And then you probably want to understand the distribution of the age of UCSD students. Then you may want to create a histogram like this. Or you want to know whether it has some outlier. You may want to create a box plot to see whether it has some outliers. Okay. So this is how you can understand the data through the EDA process. So currently in data scientists typically adopt 2 ways to do EDA. The first way I call here is called plotting-centric EDA. It uses pandas to manipulate the data, or data frame library pandas or modeling or data task to manipulate the data, and also plotting library like the matplotlib or Seaborn to plot the visualization, to plot to create the plots. Okay. The issue for that is that those plotting library is not designed for the EDA. they are designed for plotting. So there's a gap between plotting and the EDA. Say user want to understand the age column, so then they have to write code to see how I can create a histogram, how I can create a box plot, how I can create those statistics. Okay. So this is not good. This is not easy to use for both beginners and experts, because for beginners, they may not be very familiar to about how to write the code. Then it will take a lot of time for them to write the code to generate those visualization and statistics. And it's also not good for the experts, even if you are very familiar with Matplotlib. But whenever you have a data set, you have to do it again. You have to do it again. So you have to write lengthy and repetitive code for any data set you want to understand it. So this is not a good solution. I hope I can convince you this is not a good solution. And the second solution is called Profiling-Centric AI. So there's a very popular Python library called Panda Profiling that allow you to write a single line of code, and it will generate a comprehensive data profiling report for your data set. So as you can see here, it shows you the statistic of the data, and for each column, it shows you statistic as well the visualization of that column. It's good, it's very easy to use, but it has two other issues. First, it's super slow. So if you apply it to generate a report for data set with, say, hundreds of thousands of rows, it will take you maybe a couple minutes or sometimes 20 or 30 minutes. So we know that EDA is an iterative process, which means that you want to put the human in the loop. You want to see the visualization quickly and then understand the data and then manipulate the data and then see the visualization again. So if it will take 20 minutes to generate a report, you are not going to embed it into your iterative EDA process. Okay. And the second issue of this solution is it's very hard to customize. So for a report, it may have hundreds of parameters, and it's very hard for a typical user to know how to, say, change the number of bins for this visualization. Okay. And so how to solve it? So we propose the idea of task-centric EDA. So the key idea is we want to have a task-centric API design for EDA system. So what I mean by that? So first is so we believe that the EDA, the API have to be declarative. So which means that user just need to specify what kind of EDA task they want to do, and whether what visualization statistics will be generated should be determined by the system. So here show you one example. Say user get the data, user just want to have an overview of the data set. That's an EDA task. In order to get an overview of the data set and what visualization statistics will be created, and the system can figure it out. So that's what I mean by the declarative EDA API. So here's another example. Say you want to understand the missing value of the data set, you just need to write this function, and the system can help you to generate the suitable visualization for you. So the second idea, which make our system different from Panda profiling, is that we do not only support coarse grain tasks, like generate a profiling report for the entire data set. We also support fine grain tasks. Say user just want to understand a single column or the relationship between two columns. So then user can call a function like plot dfx, then it will generate visualization statistics for this column. Or user want to understand the relation between two columns is a more fine-grained task, then user can call this function, it will generate the suitable visualization statistics for the user. And the last aspect is that it has to be very easy to customize, because for the expert user, for expert users, we may recommend some visualization, but that may not be what they want. They may still want to customize it. So the question is, how can we make it extremely easy for experts to customize the visualization we generated? And we found that this task-centric API design won't hurt the customization. User can still provide this config parameter to define how they want to customize their visualization. We also provide a how to get feature, which I'm going to show you later, to make it easy for user to figure out the parameter fit with those EDA reports. So these three aspects that make our system to overcome the limitation of the existing solution. And in summary, for plotting-centric EDA solution, it's not very easy to use, but it's fast and also easy to customize. Profiling-centric EDA system is very easy to use because you only need to write one line of code, but it's slow and also not very easy to customize. And our solution is Pathocentric EDA, which can overcome which can achieve easy to use, interactive speed, and also easy to customize.
So Jiannan, I have a question at this point. So the profiling centric thing, that's interesting. You're basically summarizing the data and collecting a lot of aggregate statistics and then doing plots. Do you have any idea as to why that tool was slow? What was the performance bottleneck? Is it just not parallelizing things properly? Is it not using multiple cores correctly? What was the issue?
There are two reasons. First is it will generate report for the entire data set, but user may just want to see part of the data set. So it will generate a lot of unnecessary stuff for the user. So that's the first reason. The second reason is it's built based on the pandas, and it doesn't make full use of the multi-cores. And for our system, we are building based on the task. It makes it much faster. It makes full use of the parallelism. Okay.
Got it. Okay, so they were just building a layer on top of pandas. Okay, sounds good. And the next question is for the task-centric approach that you're proposing. The API that you're defining, is there some notion of completeness, like what sort of tasks are represented? There is going to be a learning curve for any data scientist to learn new APIs, right? They've already learned pandas and matplotlib and scikit-learn and so on. So now they have to learn one more library. Have you done any studies on understanding the learning curve and understanding the APIs in your task-centric approach versus them just stitching simple scikit-learn, pandas, matplotlib code together? Like, what is the productivity gap?
Yeah, we indeed did a user study. We gave a 5-minute tutorial for the user, and they can learn it in 5 minutes. So on README, we also have 2-minute video. So you just need to watch the 2-minute video, then you know how to use our system. The reason why it's so simple because it's a task-centric, because whenever user want to do some EDA task, they know what, say I want to understand the missing value. Then we have a single function and then map the task you want to do. So yeah, later I'm going to show you a demo, then you will see how easy to learn this our system. Okay,
sounds good. That's good.
Okay. Yeah, so here I'm going to show you some user feedback. So we introduced this library on Reddit, and it got a lot of attention. So this Reddit post is the most popular post on the Python subreddit on that day. And for example, this user said that this will save me so much time, even just exploring my data, not to mention coding all of it up. You've done good in the work. And we have also looked into why users like our library. So for example, there's a user who wrote articles saying that 7 cool Python package calculators are using without telling you. So that's a very catchy title. So they mentioned the reason they want to use Dataprepareeda is because it's the most comprehensive auto EDA tool. And there's also a Kaggle user, so mentioned, I recently got to know about panda profiling, which can generate EDA reporting in a few seconds, but now I found a better option called Dataprep. It is faster than panda profiling and also customizable. So that explains why users like to use our library. It's faster, it's customizable, and also very complete. Okay. I'm going to show you a quick demo so that you have a feeling about how it works. Then later I'm going to explain some technical details. So here I'm going to use a famous data set called Titanic. So so each row in the data set is a customer. So you want to build a machine learning model to predict whether this customer is going to survive or not. Okay. So first is that you can load the data and add a data frame. And then once you load the data, the first thing, whenever you get the data, the first thing you want to do is to understand the data, right? Then you just need to call this line of code called plot diff. this is a data frame, then it will generate the suitable visualization for you. So basically for every column, it will generate either a histogram or bar chart, depending on whether it's a category column or the numerical column. And you can see the distribution and of each column. And it will also show you some statistics like the number of variables, the number of rows, the number of missing cells, percentage of missing cells. It also automatically generates some data insights for you. Say this passenger ID is uniformly distributed. If you want to build a machine learning model, you should try to avoid it. Okay. And also we put the insight associated with each column. Say for the age, you can see it will generate some insight like age has 177 missing values. So you have to be careful about it when you use it as a feature. Okay. And then you find the data may have many missing values. Then you say, oh, I want to have a deep understanding of the missing value. And then you can call the function called the plot missing. Then it will tell you again, so how many cells are missing, what percent cells are missing, how many columns have missing values, how many rows have missing values. It gives you the visualization here. And say, for example, this cabin, and it's the number of missing value is 687. Percentage-wise is 77%, and also show you all the relevant visualization that can help you to understand the missing value of this data set. The histogram, the correlation of the missing value of between the columns, and the dendrogram to have a deeper understanding of the correlation. Okay. And then when you build a machine learning model, an important thing is you want to know which feature are important, which feature is highly correlated with your label, or which two features are highly correlated or not correlated. So you just need to call the plot correlation function. And oh, sorry, it's maybe I didn't define it. Correlation. Yeah, sorry about that. So so it will because there are different ways to measure the correlation. So we are going to generate this visualization based on the Pearson correlations, Spearman correlation, the Kindle correlation, and you can also see some insights about that, saying which two columns are most correlated. And then you may want to dive into a feature. Say, I really want to have a deeper understanding of the age column, and you can call the plot diff age. And then it will generate more insights about the age column, say the mean and the quantile, and it will show you the histogram, the KD plot, the QQ plot to compare it with the normal distribution, the box plot, and also the value table. And here I want to show you the why it's very easy to customize, and why it's very easy to learn the API. Say you just want to display the histogram. What you can do is you can copy the histogram, and you can have the display. Then it will only show you. Sorry, something wrong. Precision. Histogram. Okay, I don't know what happened, but this is okay. So let me try it again, and histogram.
Is the order of the arguments swapped?
I don't think so, but maybe. Oh, that's right. Thank you.
Well, at least that makes the API very intuitive to debug.
Okay. Yeah, right. So then you get the histogram, right? So then you want to know, they change the number of beans. Then we can show you how to do it by click this question mark and say the number of beans currently is 50. Then what you can do is you can do the config, then you change it to say 200, then it will change it to 200. Okay, so it's very easy to customize and guide the user step by step and to eventually get the visualization they want. Okay, and also if you want to understand the categorical column, you just need to do the same thing. You don't have to specify the categorical column. Then we are going to detect it for you. You can see the visualization we generate for name is different from the visualization we generate for age. So you can see we generate word cloud because it's a category column, okay, word length and value table. And then you can also try to understand the relationship between columns, say plot diff age and sex, and it will generate the corresponding visualization, the box plot and the line chart, showing this the distribution of the female, the distribution of the male. You can compare between them. It's the age and fair. It will because both of them are numerical, so it will generate the scatter plot, has-been plot, and the box plot. Okay. And sometimes you may want to compare two data frames, say the training data, test data. You want to compare them, or new data, old data. You want to compare them, or the training example whose label is positive, the training example whose label is negative, you want to compare them. So we also have a function called plot diff. Then you can put the two data frame, then it will compare the two data frame. So again, so you can see it will the data frame 1, the blue is the data frame 2, the orange. You can see the distribution of the same column between the two data frames. So then it can help you to identify some abnormal behavior of the data set. So like the pattern profiling, we also provide a function called create a report, and you can run it. Will generate a comprehensive report for data frame, but compared to pattern profiling, so we are actually much faster. So you can see it will generate a comprehensive report in the HTML page. Then you can share it with your friend or your co-workers. Okay. All right. So this is a quick demo, and I'm going to dive into it.
We have a question. Sorry, quick question on the chat from Raj. Raj, would you like to unmute and speak?
Oh yeah, so I was just like curious to know, like when you're doing EDA for like numerical versus categorical columns, how do you make the distinctions?
Yeah, currently we are using pandas because pandas can tell us is a numerical or categorical, and we just use what they tell us to make the decision. But we do find there's some situation it makes the wrong prediction. I think it's an interesting problem to explore how to improve the accuracy. Thank you for the question.
So that was Raj's paper at Sigmund this year, Jiannan. He actually had a paper on feature type inference. And so the reason he's asking this question is often there's a lot of categoricals that are stored as integers, and pandas wrongly recognize them as numeric. So it seems like there's a scope for plugging in the feature type inference models that we've built into Dataprep, this tool, Raj. We should probably follow and chat more.
Yeah. I actually read that paper, so we can definitely follow up on this to see whether we can improve the accuracy.
Sounds good.
All right. Yeah. So let's briefly explain what happened. So imagine user just put this length code, which I want to understand the price column and the number being 50. And Dataprepareeda can magically generate the visualization, say the city, the kilogram, KD plot, Q plot, and dot plot for you. The question is, first is how Dataprepare figures out why the kilogram, not other visualization. The second is, so we actually come up with a collection of mapping rules, which can map EDA task into a set of visualization, which I'm going to show you later. And the second challenge is once we know these are the visualization we are going to generate it, how can we quickly generate them? Because the latency is super important for the EDA tool. We want to generate them as fast as possible. So we come up with a very efficient data processing pipeline, which I'm going to explain to you later. Okay, so for matching rule, what we did is we did a lot of survey. We read the online blog posts and read many paper published in statistics and machine learning. And a key observation we found is that for many EDA tasks, there are always some common visualization that people want to create. Say you have a numerical column. Basically, whenever data scientists want to understand a numerical column, they are going to create histogram. They are going to compute the mean, median, max, mean, or they are going to create the box plot. So what we did is we just identify the common visualization that data scientists want to do for every EDA task, and then write them in terms of the mapping rules. So here, for example, when user run this function, we are first going to detect is a numerical or categorical. Then if it's a numerical, it will generate this list of the visualization. If it's a categorical, it will generate this list of visualization. So we didn't use machine learning to do the recommendation. It's just a set of predefined rules. So then, of course, those rules are not perfect. And what's nice about our system, because it's open source, when user saying, oh, you didn't generate visualization I want, they may submit a pull request or create an issue. Say this user say, is it possible to add a variant plot to the plot function? And then we are going to discuss with the user and then eventually decide whether we want to revise our mapping rules or not. Okay, so that's a mapping rule part. And for the data processing pipeline, it consists of three main parts. The first module is the config manager. So basically, there are a couple of the default parameters. For example, what are the default parameters for the number of bins, or the default parameter for the box plot? We have a set of default parameters, but if the user want to override them, we are going to update them. So basically, we are going to generate a config in the JSON file that show the parameter associated with all the visualization here. And then we are going to go through two modules. One is the compute, the other is the rendering. So here we make a decision, we make a design choice, which we separate compute and the rendering. So there are two things. First is we found that if you just generate each visualization independently, you actually have some redundant computation that can be shared among the visualization. For example, for say box plot, you are going to compute the percentile. But for statistics, you are also going to compute the percentile. Why can't we share the computation and compute it once? So that's why we separate them. So that's one reason. Another reason is we just find that sometimes people just want to use our compute module to generate the intermediate results, and then they want to visualize it in a different way rather than using the vocal. So that's the two reasons why we separate these two modules. So the compute will take the data and config and generate the intermediate that will be used to create those visualizations. And the render module will take the intermediate and then use a vocal to generate the visualization. So as I mentioned, if you want to use a different library to do the visualization, you can still use our compute module to generate the intermediate, and then you can use the intermediate to generate the visualization you want. So we did some experiments. The first experiment we did is we want to ask whether those functions can complete within interactive response time. And so we get 15 data sets from real world data sets from UCI, and here shows the characteristics of the data set. So what we did is for every function, we applied to all the data. And then, for example, for the plot df column 1 function, we applied to every column of all the data sets. And then we count what percentage of function can be complete, say within 0.5 seconds, or within 1 second, or within 2 seconds. So we found that over 90% of those functions for those data sets can be complete within 2 seconds, which means they can achieve the interactive response time for those data sets. And we also did a testing for another function. And you can see for this function, which try to understand the relationship between two columns, all the function can finish within 2 seconds. Okay. And we also compare with Panda profiling, and in terms of creating report. And so column represent the time that take for Panda profiling to create a report. And this column represent time for us to create a report. So as you can see that we are much faster than Panda profiling because we are using Dask. And so there are two reasons. First, we are using Dask. Second is we can share the computation between visualization to avoid unnecessary computation. And so we are basically up to 20% faster compared to Panda profiling. So in summary for Dataprepareeda, so in terms of innovation, this is the first Pathocentriceda EDA system in Python. And we built a system to show that it is possible to achieve 3 design goals, easy to use, interactive speed, and also easy to customize.
So Jiannan, quick question on the interactive speed stuff. It's obviously a function of the data set size, right? The data sets you showed were all pretty small. They're under 100 megabytes. On a machine these days, you could easily analyze data sets at a few gigabytes. And so the question for you is, in the past, in the approximate query processing world, they have explored setting hard time limits as a user constraint. They say, I want the answer in 2 seconds, get me the best possible estimate for these statistics, you know, like an approximate sample or something like that. Have you tried something of that sort? Because it seems like if you're just running the computations directly on Dask, it'll scale linearly with the amount of data, right? So it can still go into like tens of minutes. Have you explored the possibility of AQP style stuff where user can specify a time constraint as well?
So for now, not yet. But for our computation, we do have some approximate computation. Say when we calculate the distinct values for each column, we actually use hyperlog to compute the approximate count. But we haven't tried other approximation techniques to do it. And but this is a very interesting direction we can explore. Another thing is for Dask, because it can also scale to in a distributed environment. Say if one single machine is not enough, you can always deploy it in a cluster. And for our library, you can actually use a cluster to manipulate the data as well. So that's another way to solve this interactivity issue.
Got it. So the next question regarding that is, have you looked at the speed up behavior when you change the number of cores and number of machines? Right now it's a single machine system. For changing the number of cores, like what degree of parallelism do these workloads have? Like Dask is a task parallel system. So if you have one computation going on, then it'll probably not utilize all the cores, right? Have you looked into that a little bit more?
Yeah, we actually did an experiment in our paper, but I cannot remember exactly the speed up. So what we did, we varied the number of the nodes from 1 to 8, and to see how the speed up goes, how the response time change. And what we found is that it seemed like the I/O is a bottleneck, and because if you have multiple nodes, which means that you can read the data in parallel, so then it gives you a very good speed up. So for the experiment we got.
Sounds good. Thank you. Yeah, I think the choice to build it on Dask is a good one. Dask is a mature system that's actually growing rapidly. A lot of domain scientists are also adopting it in the PyData stack. And we've also compared Dask with a lot of stuff in our own kind of machine learning systems work. I think that's a good one because it allows you to scale beyond the limits of a single machine memory, and it allows you to parallelize really well. Very cool.
Yeah,
Thank you for the demo.
Yeah. Okay. Thank you. Let me see how much time I have.
So we have.
So I have only.
Sorry, we have till 3 where the audience can leave after that, but the slot we can go on till 3:15 if you want.
Oh, 3:15. Okay, so I see. So because maybe there's another demo, I'm not going to show it, and I can, if I have time in the end, I can show it again. So we also apply the task-centric idea to data cleaning, and so data cleaning basically means you have a dirty data, and you want to transfer it to a clean data. In order to do that, it has a bunch of tasks you want to do. So here's one example. Say I give you a table like this, and I want to clean it. So you are going to see many issues for the data set. Say the column, it has a special character which you want to remove, or the phone number and it's not standardized. You want to standardize it. Also for the dates, also then it's not standardized to standardize it. And for the city and the typo and the duplicate value, you want to remove the duplicate values. And so basically you have a bunch of tasks you want to do. You want to clean header, you want to clean phone, you want to clean date, you want to clean duplication. So I actually have a demo, which I'm not going to show today due to the time constraint, but later, if I have time, I can show it. And another module that we built is called connector, so that allow data scientists to use a single system to get data from a variety of data sources, like the API or the databases. And compared to existing solutions, there are two advantages. First is you don't have to download many libraries in order to get data, say from Twitter, from Yale, from DBLT. Just use our library. It's a central point that you can connect to many data sources. Second is it's very fast. And for example, we compare our system with pandas.recycle, and the connector X is our system, and we are actually 10 times faster than pandas recycle. And because of we are implementing using Rust rather than Python. That's one reason. Another reason is we get the data in parallel from the database rather than from a single connection. So that's why we can get a 10x speed up. Okay. All right. So so in the end, I just want to share some experience that I learned from open source software development. So I found that developing open source software is not easy. It's even hard. It's even harder in academia. And here I listed some challenges that are unique to academia set, and I'm also going to talk about how I address those challenges. And the first one is in academia, compared to company, we cannot talk to many user customer easily. So it's very hard to find users needs. So that's a challenge one. Second is in academia, we should publish paper. And that's another challenge that doesn't exist in industry setting. Third challenge is student continuity, which means students are going to graduate in a couple of years. And if the main developer of the system graduate, how can you still keep your system going? And the last one is about community building. It's also very new to our in the academic setting. So for the further challenge, how I think we can address it. So what I think is what we can do is we can try to read posts from hyper forums such as Reddit and Stack Overflow. Because in many situations, when data scientists encounter some challenges, they are going to have a post in those hyper forums. So if a lot of data scientists ask the same question again and again, it means that it may be an issue that we have to solve. And actually, I learned it from Sumit Guvani, who is a well-known researcher at Microsoft Research. And he told a story about his famous flight field system. So he said that one day he was in an airplane, and there's a lady who was sitting beside him, and they had a chat. So that lady asked him, "Where are you working? Where are you working?" He said, "I'm a researcher at Microsoft." And that lady was very happy, and that lady took a laptop and asked him that, "I have a spreadsheet. There's some strings, and I want to convert it to another format. Can you help me to do it?" And Sumit said, "Oh, sorry, I cannot do it." So he was quite embarrassed because he worked at Microsoft. He has been working on program synthesis for many years, but for this simple issue that he cannot answer. So after that, he actually read a lot of the posts from the hyper forums of the Excel and try to identify what are the common data translation issues that Excel users typically have. And in this talk, he mentioned he spent 3 months in just reading those posts, and then he maybe just only spent 1 month to build a prototype to do it. So his point is that if you want to make a big impact, try to spend time to figure out what are the important problems to work on, because the time you spend in working on a wrong problem may be the same as the time you spend in working on a right problem, but the impact of working in a right problem which much higher. So what we did is, for example, for this recycle, the reason we want to solve it, we also read the post from the hack forum, and we found that, for example, this user mentioned a simple query as this one takes more than 11 minutes to complete on a table with 1 million rows. So that's motivate us to try to solve this kind of issues. Okay, so that's the one. That's how we can address the first challenge. And for the second challenge, is in academia. When we build an open source software tool, we want to solve this optimization problem. We want to maximize the impact. Here, the impact is measured by the number of users, but we also want to publish papers. Okay, so then these two are kind of contradictory, because if you want to maximize the number of users, typically you are going to go with simple solutions. But if you want to publish a paper, typically you are going to solve those hard problems and come up with complicated solutions. So which make it very hard to design a system. So I'm also struggling, and what I did is I just get rid of the constraint, because at that time I've already submitted my 10-year package. I think I don't have to pay so much attention to the number of paper I can handle safe. So I get rid of it and just focus on maximizing the number of users. And it turns out it helped me make a lot of right decisions when building the data prepare systems. For example, if I maximize, I focus on the technical depth, I'm going to use machine learning to figure out what visualization we should recommend to the user rather than use the matching rules. And but using machine learning has all kinds of issues. It may make the system very, very hard to use. And but it doesn't mean that you cannot publish a paper, because once you have a successful system, you may encounter many problems you didn't anticipate, and then you can write a paper to talk about how you solve those problems. For example, for SFU boost, I'm pretty sure when the first author, Tianqi, is building SFU boost, his goal is not to publish a paper at KDD. He wants to build a useful system. But when the system has become very useful, very popular, he read a paper, and it turned out that this paper is very, very impactful, got over 13,000 citations in just 5 years. And same thing for scikit-learn. So, and I think those people are not focused on writing a paper, they just want to build a useful system to solve the machine learning pipeline issue. But if you like the number of citations of this paper, it's also very impactful work. And fortunately for our community, the senior people have already realized the issue about publishing paper while building the system. They recently launched this the Data-Centric at both Sigmod and VLDB, and Arian is also involved in launching this track for the VLDB. So what's nice about those tracks is they put more focus on whether what you do is useful, and they pay less attention to the technical depth. And it means that if you build a useful system, you solve some interesting problem, you show it useful, then you still have a high chance to get a paper published. Okay, so that's how I address the second challenge. And the third challenge is about student continuity, because for master students, they typically graduate in say 1 or 2 years. For PhD students, they graduate in 5 or 6 years. And how can we? But for project, it may last for 10 years. So the question is, how can we make sure the project is fun when students, some key member of the project graduate? So I think that the way to solve it is to get more people involved. Okay, and so this is the number of the students who are actually contribute to this project. And this getting more students involved is easier for junior students because juniors want to get involved because they can learn new things. They can put this on their CV saying that I'm contributing to a very popular open source project. But it's not good for senior people or senior students because some students have just told me that, oh, if I do it, I only need 1 week. But if I mentor a student to do it, I need 1 month. So what I did is I typically told my students this saying that if you want to go fast, go alone. If you want to go far, go together. So it means that although you can quickly complete it, but the value that you mentor students, it means that you can get more people involved. It's very helpful to our system in the long term. So then basically my students are convinced that it's good to mentor new students to contribute to the project. And here are the 4 steps that I tell new students they need to do in order to contribute to this project. So the first step is they can complete a simple task, but they are going to get full supervision from senior students. A simple task like fixing a bug or adding some documentation. And this is actually not that easy because that requires students to know how to contribute to an open source project, say how to create a pull request, how to pass all the tests in CI/DI, so how to write high quality code. So it's not that easy. It may take them 1 month to complete. And for the second step, I tell students you need to complete a bigger task, say completing a feature, but we are still going to help you. And this may also take another month for the student to complete it. And the third step is the students still complete a bigger task like a feature, but it will get limited supervision, which means they should only ask us when they have to ask us. Otherwise, they have to figure out by themselves. And the last step is the student kind of mature. So I tell students you have to propose some features for the system and then complete it with no supervision. So if you complete it, it means that you have grown to be a mentor. You can mentor new students. So that's the step that students usually go through when they want to contribute to our project. Okay. The last thing I want to talk about is community building. This is also something that we are not doing very well. So Reynolds is a co-founder of Databricks, and he has given a talk and in a database conference. He mentioned that if you want to make your open source project successful, you have to spend 50%, half your time on the community building. So half of the time on the community building, that's a lot of time. So for us, maybe we currently only spend 10% of time. But I do feel like it's super important to build a community if you want to make the project be successful. So here are a couple of the suggestions I have if you want to build a community of your open source project. The first thing is to be super transparent for your project. So which means that whenever you make any decision or deciding to add any feature, to post it on your GitHub and collect the feedback from the community. And whenever you have some meetings, and post the meeting notes on GitHub so that the user knows what happened to the project. So here's one example. For our Connector X project, we want to know what data source we want to support. And then we create a post on the discussion panel in GitHub. And then we got a lot of response. For example, this user said, please add the ClickHouse. And then we are going to discuss with the user and then finally decide what data source we want to add. The second one is to be engaged. And so because typically users, they are kind of shy when they ask the questions. And if they ask the questions, we have to engage them so that they can feel this community is very friendly, and then they can stay with the community. So as you can hear, is whenever user asks a question, we engage them and then discuss with them and try to help them to solve the issues. And the last one is building a big and successful open source project marathon, and try to give your project at least 5 years to grow, because for Postgres, it has 25 years of history, and for Pandas it was built 13 years ago, and for Spark it was built 11 years ago. For your project, maybe at the beginning it's not very popular, and it's fun because once you keep improving it, eventually, if you think there's a right direction, and once you have the best system in the domain, and people will know it through word of mouth, and then eventually it will grow exponentially and become a very popular project. All right, so in summary, in this talk, I try to answer 3 questions. First is what makes data preparation hard? And I listed 3 things. First, data preparation is not a single problem. It consists of many tasks. And also humans have different levels of expertise, and also it's domain specific. Second is why has this problem not been solved? And from the academic perspective, because we focus less on the system building. From the industry perspective, we focus on less on notebook GUI. The last is the way, I think the right way to solve it in the next decade is we should work together to build a system. And here I present 2 ideas. One is that we can have the task-centric API design. Second is we should embrace open source and get user feedback and build system together with the community. So I hope that by 2030 and the next decade, when data scientists have a tweet, they are not going to complain about data preparation. They can say, thanks to the database community, I finally stopped complaining about data preparation. Okay, thank you very much.
Love that tweet. Thank you, Jiannan. Let's give him a round of applause. I think the other faculty had to leave. Thank you for the wonderful talk. Very exciting stuff with this Dataprep library that you've been building the system. And it's great to see all this adoption. Thanks for also sharing the tips. I'm sure it's very helpful for our students too. More questions from the audience?
Yeah, I have a question. So thank you for the talk. So you mentioned like a lot of like leaning operators. So to me, it seems that they are like very type specific, like for country, you do a certain thing, like for phone numbers, you do a certain thing. So how much general purpose is that? So given any arbitrary column, like how would you know like which operator to apply?
Yeah, so this problem is a semantic type detection problem, which we want to know the semantic type of the column. And what we do is currently first the user, if they need a phone number, right? They know the semantic type, they can specify the right function. But I do think that we can do some recommendations, say by looking at this column, and then it's very likely to be a date that we can recommend some function for the user. And currently there are 2 ways to do the semantic type detection. One is using the regex. And for example, if you find they all follow the telephone number format, then maybe it's a telephone column. Another way is through the deep learning. So there's a famous system called Sherlock from the MIT. They use deep learning to do the semantic type detection.
So like given a new column, would the user will have to like keep registering the new cleaning operators? Like say like right now, if we don't support a cleaning operator for state type, then would the user register like the state type cleaning operator?
So you mean that if we don't support that tab, then we cannot support. Yeah, then okay, user have to clean by themselves.
Okay.
Yeah.
So Jiannan, longer kind of scope question, larger scope question. You say there's too many tasks. So then what is the hope for abstracting it into a library where they can learn the API? Isn't like one of the inherent challenges of data cleaning is that it's very bespoke. You also say it's domain specific. Often it's very task specific and data set specific, the kinds of errors that arise and stuff like that. And so that's why people like these direct editing interfaces like data frames and spreadsheets and trifecta and stuff like that. what is your take on where this landscape is going to evolve? So EDA part, I get the understanding of the data understanding and data exploration, but this data transformations and editing that is needed for cleaning, it seems like it's death by 1,000 cuts. There's going to be a huge amount of custom code that is still needed on top of whatever commoditized libraries like this can provide, right? What's your take on that?
Yeah, so I totally agree with you. I don't think I'm able to complete this mission by myself. I think it will be a community effort. What I hope is when we solve a data cleaning task, we can have a task-centric API design. And then if everyone builds our solution using task-centric API design, which means this task, a single function call, then the next question is how we can put them together and then have the user to figure out what should be the right task, right? So for example, for our connector X, we didn't include it into our Dataprepare library. It's a standalone library. But what we did is we just, it's not part of the Dataprepare, but we just add a dependency to that library. And anyone can use that library, a standalone library, but for us, it's just add a dependency, and then we just support that task. So imagine that in the future, for example, the feature type detection you are building, you can have the task-centric API design, and then I can incorporate it as a library in Dataprepare. Then others can also incorporate it, and then eventually we cover many tasks together, and then people can just compose those tasks to solve their own need. So that's how I think we can.
It seems like what you're saying is this need for some sort of standardization or standards mechanism, right? Like in the electronics community, they have standards communities, and like benchmarks, we have the TPC. This is part of the panel discussion too. There was a discussion that there needs to be some reference tasks and data set that community should agree on. Do you think that is feasible? Like, it seems like everybody's publishing their own papers. Like, even with the sorting hat stuff, one of the things we have decided is like we are defining some of these tasks that we're going to study and look at benchmarks for, but the set of tasks that these platforms want to implement is pretty large, and not everyone implements everything. Some of them have certain catch-all mechanisms to avoid implementing certain tasks. Do you think there is a need for a consortium of some sort, bringing academics and industry together to agree on some vocabulary for tasks?
I think there are certain tasks that can be benchmarked. For example, clean date, right? You have a data count, you want to standardize it. Why can't we benchmark it? You have the address, we want to standardize address. Why can't we benchmark it? I think there are certain tasks we can benchmark it, but there are also some certain tasks that require human. It's very, it's not well defined, right? And you see a supporting data, then you eventually find out, oh, this part is wrong. Those kind of things we cannot do anything to benchmark it. Yeah, I think we can separate the two. For the one well-defined, let's benchmark it and build a better solution. And for the other one, we can have a better EDA tool, right, to help user to understand the data.
Right. Even for the former, I'm saying there's no consensus in the community on what is the set of tasks that is complete or even close to complete. Like, is there an 80-20 rule here? Yeah, I don't know. We've been thinking about this. There are certain tasks that we know are absolutely necessary to be done by every platform. And so those are like a very minimal, small set. But what is the number of tasks that are out there? We don't know, right? That are well-defined.
Yeah, there will be a lot. For example, for our clean module, we have implemented over 100 functions.
100.
Yes, 100 clean functions, right? Say you want to clean the credit card, right? You want to clean the IP, you want to clean URL. Yeah, so for basically for any type you want to create, and then how can we have users standardize it? Yeah, it's very hard. I don't know the number, and but I think what we can do, we just build it and the user use it, and then if they are not happy, then they will complain, right? And I can show you. For example, we have the clean date, right? And then this user say I use clean date, and it gave me this is my date. It doesn't work, and can help me to figure it out. And this user even tell us how we can figure it out, right? And this is a clean country, and these users say that I do this, it doesn't work, and then we try to help user to figure it out.
So then the next natural question is, folks like Trifacta and the Excel folks, they are using program synthesis and the machine learning, and also a combination of the two, to make suggestions and recommendations and kind of semi-automate some of these tasks. Do you see scope for incorporating those sorts of techniques in this Python environment, in this notebook environment? It should be possible, right?
Yeah. I think it's possible. I know Microsoft have already built a tool that can incorporate in the notebook environment.
I see.
And they can automatically generate the code for the user. Yeah, it's possible.
Okay, so there is some work already happening in that space. Got it. Okay, cool. Sounds good. So any other questions from the remaining students? If not, we are at the end of the slot. Thank you again, Jiannan, for visiting us. And this was wonderful discussion.
Okay, thank you so much for inviting me. Okay, take care.
Bye.
Bye.
Thank you. Bye.